Hi there, in this video I'm going to do a revision question on differential equations. So let's take a look at this question. Question 3. Solve the following first order linear differential equations and in part C, cos x dy over dx plus y sin x equals sin x multiplied by cos cubed x. So let's think about the method. Let's get back to the paper and pen. So here is our differential equation. Now the question did say that it's a first order linear differential equation. Now I want you to understand that if the equation is first order linear, remember it's an equation of the form dy over dx plus px into y is equal to q of x, where qx and px are functions of x. So in other words, if you have an equation of this type, you have a first order linear differential equation. So FOLDE stands for first order linear differential equation. Now, first of all, it doesn't look as if it's quite a first order linear differential equation because you have a cos x term as a coefficient of dy over dx, but we can get rid of this cos x term in order to make it a first order linear differential equation. So let's do that. So if I divide every single term by cos x, so let's divide by cos x. By doing that, we're going to end up with dy over dx plus y sin x divided by cos x, and that is equal to sin x cos cubed x divided by cos x. So that is what you should have as a result of dividing by cos x. Now sin x over cos x we know is tan x, and I can cancel one of these cos terms with one above, leaving me with a cos squared x term on top. So let's rewrite this as dy over dx plus, and as I said, sin x over cos x is tan x, so y tan x, that is equal to sin x cos squared x on the right hand side. Now let's think about the method. So just as a reminder, I've created a screenshot explaining the method step by step. So to the screenshot, step number 1, we need to write the given equation in standard form. That is, we need to make the coefficient of dy over dx equal to 1. So back to the paper and pen. Now as a result of our rearrangement, our equation here is in standard form. So the reason being is because the coefficient of dy over dx here is 1. So since the coefficient of dy over dx is already 1, this equation here is in standard form. So SF is my shorthand for standard form. Now what I tend to do is I name my standard form equation star. So let me immediately call that star, the standard form equation. So this is step number 1, remember, of the process. Now let's go to the screenshot. Let's see what step 2 is about. Calculate the integrating factor IF, and to work out IF, the integrating factor, the formula is e to the power integration of px with respect to x. And there is an additional note that I've made. If the power when integrated contains ln, then use the result e to the ln a equals a to simplify further. So back to the paper and pen. So in this case, our px term is the coefficient of y. So the coefficient of y is plus tan x. So let me make a note that px is plus tan x. And as a result of our px, let's calculate IF, the integrating factor. So it's e to the power integration of px with respect to x. So that being the formula. And if I replace px here, I'll have e to the integration of px, which is tan x, with respect to x. Now, let's go one stage further. So e to the power, integration of tan x is minus ln cos x. Now, if we go back to the screenshot, if our power contains ln, then it's recommended to use this result to simplify further. Remember the result, e to the ln a equals a. So let's use this result. Back to the paper and pen. Now, using one of the laws of logarithms, I can take that minus in front and rewrite it as a power using the power rule. So I can write this as e to the ln cos x to the power of minus 1. And remember the result from the screenshot. Since e to the ln a is a, that would make e to the ln cos x to the minus 1 cos x to the power minus 1. And cos x to the power minus 1 is the same as 1 over cos x. So that should be if, the integrating factor. Now, let's go back to the screenshot. Let's see what the next step's about. Step number 3, multiply the equation in standard form, which is star, by if. So we need to multiply every single term in that equation by the integrating factor. Back to the paper and pen. So here is step number 3. So in step number 3, we need to take this integrating factor, 1 over cos x, and multiply this equation here by that term, which is if. Let's do the multiplication. 1 over cos x times dy over dx is 1 over cos x dy over dx plus y tan x times 1 over cos x is y tan x over cos x. That is equal to, and sin x cos squared x times 1 over cos x is sin x cos squared x divided by cos x. Now, I'm not going to tidy up the left hand term. You'll see why when I go to the next step. But for the right hand term, let's tidy this up. Cos x on the bottom will cancel with one of them on the top, leaving me with sin x cos x on the right. So with this in mind, let's go to step number 4, back to the screenshot. So by the product rule, the left hand side of the equation can always be rewritten as d by dx of if times y. So back to the paper and pen. So the left hand term, this entire term on the left, you can always write that as d by dx of if into y. So let's use this result. So we're going to end up with d by dx of if, bearing in mind that is 1 over cos x into y. That is equal to the right hand term, which is sin x cos x. So that is the equation that we'll end up with as a result. Now, this is no trick rewriting this term here in this form. Take it from me that if you differentiate 1 over cos xy with respect to x using the product rule, you're going to end up with this term on the left hand side in its entirety. Now, back to the screenshot. Step number 5, last step, so we're almost there. Integrate both sides. That means that we need to integrate the left hand side as well as the right hand term. So back to the paper and pen. So let's integrate both sides. Let's do this on the reverse. So here is step number 5. So step number 5, integrate both sides. So if we integrate, so going to the reverse, if we integrate something that we differentiate, we're going to end up with this term, which is 1 over cos x times y. So let me copy that down. So 1 over cos x times y. So we'll end up with this term on the left. However, we need to integrate sin x cos x on the right. So we now need to think about integrating sin x cos x on the right hand side. So let me call this integral on the right hand side number 1. And let's think about how we can solve number 1. So number 1 is the integration of sine x cos x. Let's think about how to integrate this as a side calculation. Now there's two methods to integrate this integral here. You can use substitution, so you can take u as sine x or even u as cos x and use substitution to tackle this integral, or we can use the double angle for sine. So let me show you how to integrate this, because remember the double angle for sine 2x, so this is the double angle formula, that is 2 sine x cos x. Now in our integral we have sine x cos x, so if I rearrange here, I'm going to have sine x cos x, that is sine 2x divided by 2. And as a result of that, I can rewrite this integral as the integral of sine x cos x, which is sine 2x divided by 2. And let's integrate that with respect to x. If I integrate sine, that is minus cos, so it's a minus cos 2x divided by, keeping this 2 here, you also need to divide by 2 also. So be careful, when you integrate sine 2x, it's minus cos 2x over 2, but don't forget this 2 already here, plus the c for completeness. And if we tidy this up, we'll end up with minus 1 over 2 into 2, which is 4, cos 2x plus c. So that should be the solution to the right-hand integral. As I said, there's two methods to integrate this one. You could also use substitution. You can either take u as sine x or u as cos x and use substitution. Now going back to this main calculation, so for the left hand term we have 1 over cos x times y. And as a result, for number 1, when we integrated, we've got minus 1 over 4 cos 2x plus c. So let's tidy this up. So we have y over cos x on the left hand side. On the right hand side, it's minus a quarter cos 2x plus c. So let me leave my solution like this. So this should be the solution to question 3 part C. Now, if you're not sure about the concepts that I've used to solve this question, I have created videos explaining the method in greater detail along with additional examples, and I'll provide links to these videos in the description below. So be sure to check out these videos. Other than that, I hope you enjoyed this video. I hope you found this video helpful. If you did enjoy the video, a like rating is very much appreciated. Do plenty of practice related exercises, and I hope to see you again. Thank you.